How do we predict where an object will be at a later time? This is the question that students will explore in Investigation 3B, Motion Graphs. In Investigation 3B, students will practice using the motion of a smart cart to match velocity time graphs. In their explorations, students will develop an understanding of the relation between the cart's motion and the velocity time and position time graphs that describe its motion. For this investigation, each student group will need a smart cart and a track with feet. Parts 2 and 3 use an ebook simulation. In Part 1, students will move a smart cart on a track to match velocity time graphs. First, we will place the cart in the center of the track and, if necessary, adjust the track feet to level the track. For this investigation, it doesn't have to be perfectly level. Each group will open the experiment file, 3B Motion Graphs, in SparkView. And then turn on their smart cart and connect it using Bluetooth. For each velocity time graph, students will sketch a prediction. As an example, when the velocity is small, constant, and positive, the position graph will have a small, constant, and positive slope. Students can play with the motion of the cart and find that moving the cart slowly forward will agree with the velocity time match graph. Let's give that a try. Use the position time plot from your motion to sketch the actual position time graph on the same plot as your prediction. Your student's actual may or may not match their predicted graph. Either way is fine. Each of the other 3 velocity time graphs has a separate page in SparkView. We started with the forward at slow speed, go to fast speed, have backward at slow speed, and backward at fast speed. Before collecting data for each new page, students should hide all of the data so that the graph is blank. Students will follow the same process of predicting, matching the motion, and drawing the actual plot for each of the velocity time graphs. And then they will answer questions A through E about the graphs. In Part F, on page 3, students will combine their ideas from the velocity time match graphs and the position time graphs that they have created. Before recording data in Part 1F, students should go to the 5th page of the SparkView experiment file and hide all of the data so that the graph is blank. To match the position time graph, the cart must begin at rest and then move in the positive direction, move in the negative direction past the origin, and then move in the positive direction again, but slower, ending at the origin. We'll start collecting data with the cart at rest, move it forward quickly, then backward quickly beyond the origin, and then forward slower, ending at the starting point. Let's collect some data and see how it looks. Students will describe the motion of the cart for each segment of the match graph. In Part G, students will draw the velocity time graph for their motion. I'm drawing it over the teacher key so you can see that it might not match exactly. In Part H, students use the slope tool in SparkView to find the slope of each section. To use the slope tool, I will choose a point, click on it, and then click on the slope tool icon. The slope that I find here is 0.26, and you'll see that that's fairly reasonable in this region. So for section D, the slope of the position graph and the velocity are similar. The similarity will be clearest to your students in the regions where they have matched the graph most successfully. Part 2 uses a simulation found on the ebook. This interactive is found on the 3B investigation page in Chapter 3 of the ebook under Part 2. The goal is to match targets on a position versus time graph by adjusting the initial position and velocity variables. If I look at my targets, I can see that a line going through them is going to start fairly close to the origin and move up to probably about 2 meters. So I'm going to start with an initial position of 0, and I'm going to choose a slope of 2 meters over 10 seconds, which will give me about 2/10. And we can look at the score of 78, which could be improved somewhat by adjusting the slope slightly. We can also run the simulation to see what the cart would look like making this motion. In this case, it's just going in a straight line between 2 points. Comes fairly close, it's within the little red targets. Now, you can imagine a time when the cart might be moving in different directions, forward, backward, faster, slower, and in fact, that's what we're going to be working on next. It's possible to fix your scores, make them a little bit better, or you can leave them as they are, and the students can answer the questions using what they've learned from the simulation. Part 3 uses an interactive model with 4 segments that has initial position and velocity values that can be adjusted to hit the targets. This investigation is in Part 3 of Investigation 3B. Our goal is to pass a line through the center of each of 4 targets by adjusting the value of the initial position and the velocities for each of the segments. The graph is divided into 4 2.5-second segments, so I cannot just go from one point to the next because the slope will only work for the first target. Students will play around with this, but one strategy you could use is to start with a flat line for the first segment. This passes at about -0.5. And we get a line that actually goes through the first 2. But when we get over to the third one, we see that we're going to need to put some sort of slope in, and in this case it would be a positive slope. And we are going from -1/2, let's see where it would pass through. It would pass through at about 1. So we're going to put in a slope of, we don't want negative. Let's do a positive 0.8. And you see it passes through the target. It's a little bit on the high side. If we were to drop that just a little bit, then we could probably get it through the second portion. But you can see that there's a score here of 44, which will improve with each adjustment that you make to the slope. Students can practice their skills in working on the slopes on this particular interaction and also in graphing position and velocity versus time on their own or in groups. Pages 6 and 7 of the student worksheet have a set of slide presentation graphs that they can do with their teacher. And starting with page 8, applying new knowledge gives them another set of practice questions.